An AI says that it cracked a math problem that beat people for 50 years. It spun up 64 agents, some explicitly told to break the other's work, and finished in under an hour. But for now, we still have to just take its word for it. It wrote what is basically a mathematical essay, and essays need experts. It will take a handful of them weeks of their time. The fix for that has existed for 60 years. Proofs written so a computer checks them itself with no expert required, but until now, it's been too slow to be worth using in earnest. One theorem could eat a decade. So here's the claim I'll stand behind. AI is turning that decade into days, and when it does, math stops running on trusting only a few human experts. Come with me, let's get into it. OpenAI researcher Ethan Knight posted something remarkable. He said the company's model, GPT-5.6 Sol Ultra, produced a full proof of the Cycle Double Cover Conjecture. That problem's been open since 1973. A mathematician named George Sekaresh posed it. Paul Seymour sharpened it in 1979. Now, what does it ask? Take any network of points and connections as long as it has no weak link that would split it in two. The conjecture says that you can always find a set of loops that covers every connection exactly twice. That's simple to state, but nobody could prove it for over 50 years. Now, OpenAI says that its model did in under an hour. And I respect this part. They published both the proof and the exact prompt that generated it. Anybody can read it. Hold on though, this is still a claim, it's not settled results yet. Nobody has peer-reviewed it, and this specific conjecture has a long history of people announcing proofs and then mathematicians actually finding holes in them. So the proof reportedly reduces the general case down to cubic graphs and leans on something called the 8-flow theorem, and that's a recognizable line of attack. So graph theorists are about to spend weeks checking it line by line. Good, that is the system working. But look at how they made it, because that part you can verify right now. The published prompt tells the model to spin up as many as 64 subagents at once. That is a system allowed to run up to 64 copies of itself, each assigned a different piece of the problem. It's told to manage them, in its words, aggressively and dynamically. So some of those copies are adversarial. Their whole job is to hunt for edge cases and break every step that the others propose. No partial credit. The prompt told the system to grind for at least 8 hours before giving up, but it finished in under an hour. And within another hour, the result was on Hacker News, and somebody had already edited Wikipedia. So stay with what just happened there. A machine ran its own division of intellectual labor. It set some of its agents to build and others to tear down, and it landed on an answer to a question that people had circled for half a century. Which brings up the uncomfortable question. If a machine proves something, who checks the machine? And there is an answer forming, and it showed up the same week in London. Yesterday's edition flagged this. 25 researchers gathered to translate Fermat's last theorem into something called Lean. Lean is a proof language that a computer checks by itself. A proof written in Lean doesn't ask you to trust the author, human or machine. You run it, and if it holds, it holds. This idea isn't new. We've had this machine checkable proof for about 60 years. It's just that nobody could afford to use them. Turning one theorem into that form could eat a whole decade. The Kepler conjecture, for example, took an international team more than 10 years. So almost nothing has ever gotten done with this. But now look at that London room. Kevin Buzzard at Imperial College has been building this for years. In a single day, with AI help, the code base doubled from 20,000 lines to 40,000. That is the price falling off a cliff. One researcher there, Honglu Su, called what she's watching the industrialization of the intellectual process. And someone in the room asked straight out, if a machine proves a theorem, but no human can understand it, then what have we achieved? The plain answer is this. You write a proof in Lean, and anyone can check it. Any mathematician, any student, and any other machine. No trust is required. The catch was always the cost of getting proofs into that form, and that cost is the thing that AI just started cutting. So this particular proof might survive the next few weeks, and it might not, but either way, the machine that made checking urgent is the machine that's about to make it free. Now let's shift over to a different kind of checking of the machines the whole economy now runs on. Starting on Monday, 2 of Britain's financial regulators, the Bank of England and the Financial Conduct Authority, get direct oversight of 4 companies, the UK arms of Amazon Web Services, Google Cloud, Microsoft, and Oracle. Now here's why that's a first. These regulators supervise banks and insurers. That's their job. They've lacked direct regulatory authority over the cloud companies that the banks run on top of. Until Monday, the banks depended on the clouds. The regulators watched the banks, and so the clouds themselves sat outside that fence entirely, a single point of failure that nobody could really see inside. The government has now labeled all 4 critical third parties to the financial system. So in plain terms, that means they are essential so that if they go down, the whole system wobbles. So the regulators can now supervise them directly. The 4 firms will have to stress test their systems and report major incidents, outages, cyber attacks, even natural disasters straight to the regulators. But why now? Well, look at October of last year. AWS failed in Northern Virginia, one of the densest concentrations of cloud capacity on the planet, and it disrupted services at more than 2,000 companies. One of them was Lloyds, one of Britain's biggest banks, and over a 2-year stretch, UK bank customers logged 33 days of IT outages. Now, all 4 companies publicly welcomed the move, and the government framed it as protecting financial stability. Both of those are the actors describing their own takes on this, so take them as such. The more telling fact sits underneath that. For a decade, these platforms grew by pushing the risk of downtime onto their customers. Reliability was a private matter, and it was settled in the contract. But as of Monday, once a platform becomes foundational to an economy, then the state can enforce its uptime as a public obligation. And the direction is already marked. The chair of the Treasury Committee has signaled that AI firms should come next. That's the same logic extended from the cloud the models run on to the models themselves. Now over to something that you used to only hope for, but you can now put on a purchase order. On Friday, BYD Energy Storage confirmed that it won a contract to supply 11.275 gigawatt hours of battery capacity to a project in Abu Dhabi. The project is called Round the Clock. Masdar runs it, Abu Dhabi's state-backed renewable energy company. So here's what the full plant does. It pairs 5.2 gigawatts of solar with 19 gigawatt hours of storage, and it's engineered to deliver a steady 1 gigawatt of power every hour of the year. Day, night, wind, no wind, continuous baseload. So let's stop on that. For years, one of the biggest arguments against solar was intermittency. The sun goes down, the power stops, so you still need something running in the background. This plant answers that objection in hardware, a steady gigawatt around the clock from sun and batteries. BYD supplies most of the storage, and a second firm, SunGrow, takes the remaining 7.5 gigawatt hours. So 2 companies now hold the entire battery backbone of the single largest solar plus storage plant on Earth. BYD's piece runs on its Blade battery, packed 10 megawatt hours to a 20-foot shipping container, rated to work from -30 up to 55 degrees Celsius. That range is the whole trick. It means the same hardware serves a Gulf desert and a northern grid with no redesign. BYD won a similar 12.5 gigawatt hour deal in Saudi Arabia just recently on the same platform. And there's something that needs to be named honestly here. China concentrates the factories making these cells at this pace. That's the supply chain as it stands. But here's what decided it. This didn't win because someone subsidized it into existence to prove an environmental point. It won a competitive procurement on cost. Its bid priced 24-hour clean power below the alternatives. The old rule was that reliable, always-on power meant burning something: coal, gas, uranium. That rule just lost a contract to Sunshine and Batteries on price. Now let's stay with the grid because there is a companion story here. The receipts came in from last week's heat wave. Canary Media published an after-action analysis on July 10th. It looked at how the U.S. grid handled last week's brutal heat wave. And the headline seems quiet, which is exactly the point. The grid held, and nobody needed the emergency tools. But here's the setup. The July 4th edition of the Century Report covered a federal order. It gave PJM authority to do something drastic if demand outran supply. PJM is the biggest U.S. grid operator, 13 states plus D.C. It could order data centers to cut their power draw. It could fire up backup generation, last resort stuff. Demand hit records across PJM's territory. So you'd think that it would have had to actually resort to those last-ditch efforts. But it never pulled that lever. It never curtailed a single data center. Down in Texas, the grid hit an 83 gigawatt peak on July 6th. At the hardest moment to meet, solar was covering more than 30% of the demand. And up in New England, they burned markedly less oil than during last year's comparable heat wave. Here is why. New offshore wind and hydropower carried the load. It flowed over a line called the New England Clean Energy Connect, covering what oil-burning peaker plants used to do. Now, I do want to be honest about this because this doesn't move in a straight line at all. There were real reversals the same week. New York City's Champlain Hudson Power Express line shut down on July 4th over a problem on the Quebec side. That pulled a major clean feed offline at the worst possible time. And Hawaii is backing away from its 100% renewable energy target. It's leaning back toward imported LNG. Those are genuine setbacks. But step back and look at what did the absorbing part. Capacity that did not exist even a year ago. Offshore turbines, a hydropower interconnect, distributed rooftop solar, home batteries, even EVs discharging power back into the grid during the peak. The July 6th edition's podcast covered that record. In the same window, Holtec finished renovating the Palisades nuclear plant, and Bloomberg NEF now projects 44% global growth in nuclear capacity by 2036. The old framing treated a heat wave as a stress test that fossil plants passed, but clean energy failed. Last week ran the test, and the result came in the other way. In several regions, clean additions helped carry the load, and the Emergency Fossil Authority largely sat there, unused. Parts of the grid got through the crisis while burning less. One caveat, and it is a real one, federal clean energy and permitting rollbacks are moving through Washington right now. They would slow exactly the kind of additions that did that absorbing. The thing that held the grid up is the very thing that the policy of this administration would make harder to build. All right, let's bring it to a close. We opened on a question. Who checks AI's proofs? And when you put the whole day together, that turns out to be the day's real subject, the layer that we build underneath the breakthroughs to hold their weight. A model closed a 50-year proof in under an hour, and nobody can check it fast yet. It wrote an essay, and essays need experts. But in that same week, in a room in London, 25 people were building the alternative checks, proofs that a computer can check by itself. That idea is 60 years old, and it was always too expensive to use. But in a single day, with AI, they doubled it. The machine that outran our checking is the machine that is now making checking cheap. It's the same shape in every story today. Britain reached inside the cloud that its economy runs on because you can't let a platform that big fail in the dark. A plant in Abu Dhabi turned 24-hour clean power into something that you can order off a price sheet, and a grid held through a heat wave on turbines and batteries that didn't exist a year ago, with the fossil fuels-based emergency switch never flipped. None of that is the intelligence itself, per se. All of it, though, is the foundation getting poured underneath it. The checking layer, the reliability rules, the batteries and the wires, and the sunshine. So the honest answer to who checks the machine's proof is this. For today, for this one, the same few experts that it's always been. But only for this one. And only for now. The tools to check a proof already belong to everyone. What we're pouring now is the road that gets proofs to them. When you put the day down, the ground under all of this is wider and stronger than it was yesterday, poured to carry a load that just keeps growing. See you tomorrow.